Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion here is NCERT solutions to exercise number 4 for determinants. In the first problem we need to find the adjoint of this matrix. Let this matrix be A. Then we will find the cofactor matrix A11. So we can remove, this is the first element, 1 1 element. So we can remove this column and this row. So that will be equal to 4. Similarly, A12 will be minus 3. A21 will be minus 2. And A22 will be equal to 1. So cofactor matrix will be A11, A12, A21, A22. So this is what? 4 minus 3 minus 2, 1. Now adjoint A. Adjoint A will be transpose of the cofactor matrix. So this will be 4 minus 3 minus 2, 1. Now I am going to tell you one very interesting formula to get adjoint of a 2 by 2 matrix. This is a 2 by 2 matrix. So I am going to tell you the adjoint of a 2 by 2 matrix without doing all these calculations. So how do we do it? For a 2 by 2 matrix, adjoint A, the formula is like this. We will change the diagonal elements. So 1 will be changed to 4 and 4 will be changed to 1. So we will change like that. 4, 1. And the other two elements which are 3 and 2 we will change their sign. So this is plus 2, it will become minus 2. This is plus 3, so it will become minus 3. So this will be adjoint of A. Please apply this formula only for 2 by 2 matrices. Find the adjoint of matrix. This is a 3 by 3 matrix, so that formula doesn't apply here. So we can compute like A11, we know how to do it. 1 into 3, 5, 0, 1. So this will be 1 into 3, 3 minus 0, 5 into 0 is 0. So this will be equal to 3. Similarly, A12 will be minus 1, 1 plus 2, two, 5, 2, 5, minus 2, 1. So 2 into 1, 2 plus 10, which will be 12, and a minus sign is here, so this will be minus 12. A13 will be similarly 6. We write similarly other elements. A21 will be 1, A22 will be equal to 5, and A23 will be equal to 2, A31 will be equal to minus 11, A32 will be equal to minus 1, A33 will be equal to 5. So we can get the cofactor matrix, which is A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is equal to 3 minus 12, 6, 1, 5, 2, minus 11, minus 1, 5. So we can easily get adjoint matrix as the transpose of adjoint A will be transpose of cofactor matrix. This is the transpose. So just we transpose this matrix. 3 minus 12 minus 6, 1, 5, 2, minus 11 minus 1, 5. In this problem we need to verify that A into adjoint A equal to adjoint A into A equal to determinant A into I. This is a very important identity you must remember. So we will show this with this example, with this A. So first we will get mod A or determinant A. Determinant A is 1 into 0 minus 2, 0, 3, minus of minus 1, 3 minus 2, 1, 3, plus 2, 3, 0, 1, 0. On solving this we get this as 11. Now to get adjoint A we need to find the cofactor matrix as done earlier. So we'll again do A11, we calculate. You know how to do this. I will just give you one example here. A11 minus 1, 1 plus 1, 0 minus 2, 0, 3, which is equal to 0. Similarly A12 will be equal to minus 11. A13 will be equal to 0. This is an exercise for the student. They should get these values. I have told this in previous videos also how to do this. A21 will be equal to 3. A22 will be equal to 1. A23 equal to minus 1. A31 equal to 2. A32 equal to 8. A33 will be equal to 3. So the cofactor matrix we know is given by A11, A12 and A3. We'll write those elements 0, minus 11, 0 minus 11, 0, 3, 3, 1, minus 1, 2, 8, 3. So adjoint A we know 0 minus 11, 0, 3, 1 minus 1, minus 2, 8, 3. Now next we will be doing A into adjoint A. That will be our task. So let us multiply A into adjoint A. We will get a matrix like this: 11 into 1, 1, 1, 0, 0, an identity matrix which is equal to 11 is mod A or determinant A into I. So we got one side A into adjoint A equal to determinant A into I. This we got now. Now we will try to get the other expression. Adjoint A into A is equal to determinant A into I. Will do that. Similarly, I give an exercise to the student. Adjoint A into A. We'll get 11 1 0 0 0 1 0 0 0 1, which is this is mod A, this is mod A, or determinant A into I. Hence we can show that A into adjoint A equal to adjoint A into A equal to determinant A into I. This is a very important identity which you must remember. Find the inverse of each of the matrix if it exists. For a matrix to exist, first we will find the determinant A. So determinant A is 3 into 2 6 minus 4 into minus 2, which is minus 8. So this will be equal to 14. Now mod A or determinant A is not equal to 0. So A inverse exists. So we need to find adjoint A. That I told you one important formula. We'll change 2 and 3 first. So 3 will go here, 2 will come here. Then we'll change the sign of 4 and minus 2. So this will become minus 4, this will become 2. So this is adjoint A. So A inverse is 1 over det A into adjoint A equal to 1 over 14, 3, 2, minus 4, 2. So this is the result. In this problem, we need to find the inverse of a 3 by 3 matrix. So what we will do, we call this matrix as A. This is a 3 by 3 matrix. So we can first find the determinant A, whether it exists or not. So this will be 1, 2, 4, 0, 5, minus 2, 0, 4, 0, 5, plus 3, 0, 2, 0, 0. These two terms will become 0. So this will be 5 into 2, 10. So mod A will be 10. So determinant A is not equal to 0. A inverse exists. So we are going to find the cofactor matrix. To get the inverse, we need to get the cofactor matrix. So what is the procedure? Get the cofactor matrix, which is given by A11, A12, A13, A21, A22, A23, A31, A32, A33. So we will first get the cofactor matrix. Then adjoint A is cofactor matrix transpose. Then we can get A inverse equal to 1 by det A into adjoint A. This is the procedure. So first we will get the cofactor matrix. So how to get these elements A11? You know that formula is there. A11 minus 1 power 1 plus 1, 2, 4, 0, 5. This is equal to 10. Similarly, A12 is 0, A13 is 0, A21 is minus 10, A22 is 5, A23 is 0, A31 equal to 2, A32 equal to minus 4, A33 equal to 2. So we got the cofactor matrix as cofactor matrix. We write 10 0 0 minus 10 5 0 2 minus 4 2. So adjoint A will be cofactor matrix transpose. So adjoint A will write 10 0 0 minus 10 5 0 2 minus 4 2. A inverse is 1 by det A into adjoint A. So 1 over 10, 10 minus 10 2, 0 5 minus 4, 0 0 2. This is the inverse of this matrix which we found. This is the answer. Now find the inverse of the each of the matrix if it exists. So first we will find determinant A. So 1 into cos alpha sin alpha minus cos alpha plus 0 into determinant plus 0 into determinant. So these terms will be 0. Only first term will be there, which is minus cos square alpha minus sin square alpha. This is equal to minus cos square alpha plus sin square alpha equal to minus 1. Now mod A or determinant A is not equal to 0. So A inverse exists. So we know how to compute A11 minus 1 1 plus 1 cos alpha sin alpha minus cos alpha equal to minus 1. A12 will be 0, A13 is 0, A21 is 0, A22 is minus cos alpha, A23 is minus sin alpha, A31 equal to 0, A32 equal to minus sin alpha, A33 equal to cos alpha. Now the cofactor matrix we know is A11, A12 and A13 and so on. So directly we can write the adjoint matrix adjoint A minus 1 0 0 0 0 minus cos alpha minus sin alpha cos alpha. So A inverse is 1 over mod A adjoint A. So this will become 1 0 0 cos alpha sin alpha minus cos alpha. Already did. Now in the next problem, let us try to find that AB inverse, product of two matrices AB inverse is equal to B inverse A inverse. So we can first get the product AB whose determinant is given by, first let us calculate AB. So 3, 7, 2, 5, 6, 8, 7, 9. So we multiply these two. We know that the product will be -2. I'm sorry, this is a matrix. This is a matrix. So we'll get a 2 by 2 matrix. So 67, 87, 47, 61. You can multiply this row with the first column element by element, then this row with second column element by element, and get these two elements. Then we multiply the second row with the first column of this matrix, and so on. So we'll get this. Now we can get determinant of this matrix. 67 into 61 minus 47 into 87. This will be -2. Also we need to get adjoint. To get the inverse of this matrix, we need to get adjoint of AB. So we can directly get this. We'll change these numbers. So this will be 61, 67, and change the sign here. So we can get directly adjoint AB. So AB inverse 1 by determinant of AB into adjoint of AB. So this will become minus half 61 minus 87 minus 47 60. Next we find B inverse and A inverse and find their product like this. Then we can show that AB inverse will be this. So for getting B inverse, what we have to do? We have to get determinant B first. This will be 54 minus 56 minus 2. So B inverse exists equal to -2. So B inverse exists because mod B or determinant B is not equal to 0. So we can get B inverse as 1 by -2 into adjoint B. Adjoint B can be easily determined for a 2 by 2 matrix as changing these elements. So this will be 9, this will be 6, and changing the sign of the other two elements. So we got B inverse. Similarly, we can get A inverse. A inverse we can get as 5 minus 7 minus 2, 3. Now we find B inverse, A inverse product. B inverse, A inverse will be minus 1 by 2, 9 minus 8 minus 7, 6, 5 minus 7 minus 2, 3. This will be equal to minus half 61 minus 87 minus 47, 67. Hence, previously you have seen that this is nothing but AB inverse itself. So AB inverse equal to B inverse, A inverse. This is a very important identity you must remember. This we have just shown with one examples of A and B, but it is universally true. In this problem, we need to show A square minus 5A plus 7I equal to 0 and then find A inverse. So we know A square equal to A into A, which is equal to 3, 1 minus 1, 2 into 3, 1 minus 1, 2, which is equal to 8, 5 minus 5, 3. So we can show that A square minus 5A plus 7I, we'll substitute these values. This A square by this 8, 5 minus 5, 3 minus 5, A itself 3, 1 minus 1, 2 plus 7I 1 0 0 1, this will be equal to 0 0 0 0. Now we need to find A inverse. So we multiply this equation with A inverse throughout. So A inverse A into A minus 5 A inverse A plus 7 A inverse I equal to 0. So this will be I. So only A will remain. This again will vanish. So minus 5A plus 7A inverse will be equal to 0. So 7A inverse will be 5A, 5I. This will be 5I minus A. A inverse will be 1 over 7 5I minus A. So that's what we are going to do now. 1 over 7 5I is 1001 minus A. A is 31 minus 1 2. So this will give 1 over 7 2 minus 1 1 3. Let A be a non-singular square matrix of order 3. Then we need to evaluate the adjoint A. Now we have a formula here. If determinant A is not equal to 0, then adjoint A is determinant A n minus 1, where n is the order of the matrix. It is 3 here. So adjoint A will be 3 minus 1, which is equal to 2. So the correct option is B. If A is an invertible matrix of order 2, then that A inverse is what? So we know that A inverse equal to I. This is A inverse is equal to I. So A inverse equal to I by mod A, which is option B. Hence option B is correct. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.